Okay, I'm going to start talking about section 4.5 and 4.6, which is graphing trig functions. I'm going to start by graphing the sine of x. I usually do a sine of bx. In this case, a is 1 and b is 1. So, to graph these, I strongly recommend you sketch your curve first and then label your axes. It'll make it much easier. The sine wave will start at the origin. It'll go up to its maximum, down through the x-axis, and then back up. It will complete its cycle in 2 pi. It has an amplitude. This is the amplitude. That happens to be the absolute value of A. A is 1. The absolute value of 1 makes this 1. The amplitude is 1. The period is 2 pi over b. B again is 1. What's 2 pi over 1? 2 pi. So it finishes the cycle in 2 pi. Halfway between 0 and 2 pi is 1 pi. Halfway between 0 and 1 pi is 1/2 pi. People struggle with what I'm about to do, so see if you can follow along. This is 0/2 pi. This is 1/2 pi. This would be 2/2 pi. This one would be what? 3/2 pi. And the last one here would be 4/2 pi. So counting by halves is what you need to be able to do. And this is what the sine wave looks like. You've got to have a feeling for what it looks like. What would be the coordinates of this maximum would be pi over 2 comma 1. The coordinates of this minimum would be 3 pi over 2 comma negative 1. This is one cycle of a sine wave. It does continue. But I usually ask you to graph one period or one cycle. Now again, the sine wave starts at the origin. Unlike the cosine is going to start at the maximum. The amplitude is still 1, so that's at 1. Cosine comes down to its minimum and then back up, completing a cycle about here. Now again, it is a period of 2 pi over 1, which is 2 pi. Halfway would be pi. This again would be 1/2 pi, 2/2 pi, 3/2 pi, and finally 4/2 pi. So this does continue just like all waves do. So could you give me the coordinates of your maximums here? Would be 0, 1, and 2 pi comma 1. Your minimum here would be pi comma negative 1 because the amplitude is 1. So the sine wave and cosine wave are very similar, just moved over a little bit. Okay, I chose a sequence in which I'm presenting these general graph types in a very specific order. The next one I gave you is cosecant. I'm hoping you know cosecant is 1 over sine. So what I would do is sketch a sine wave. Notice I'm doing it dotted because it's not part of the actual graph. That was 2 pi, that was pi, that was pi over 2, 3 pi over 2, 0. Amplitude was 1. So I just sketched a general sine wave. Cosecant is 1 over sine. You're not allowed to divide by 0. So wherever the sine wave hits 0 or the x-axis, it creates what's called vertical asymptotes. And the actual graph itself is going to come off of these and go towards these asymptotes. They may look like parabolas, but they're really not. They're approaching asymptotes. Now what's this minimum here? Would that be pi over 2 comma 1? What would be this maximum? Because compared to points left and right, it's the highest. Would that be 3 pi over 2 comma negative 1? Now again, it continues. There are more periods, but I usually ask you to graph one cycle. So if you have trouble with the sine wave, you're not going to be able to do the cosecant. Just like the secant is 1 over cosine. If you could not graph a cosine curve, I doubt that you'd be able to graph 1 over it. So I graphed a cosine curve. There's 2 pi, 1 pi, half pi, 1.5 pi, maximum's 1, minimum's -1. And these do continue on down. Now where do these hit 0? Because you're not allowed to divide by 0. Pi over 2, negative pi over 2, 3 pi over 2, and these create vertical asymptotes. If I was to continue this down, it would hit where? 5 pi over 2, I think? 5 pi over 2. I only want one cycle, but again, the actual graph itself comes off of these and approaches these asymptotes. Now, one cycle is only 2 of them. I think I actually graphed 3 of these. That would be 2 pi comma 1. This would be at pi -1. This point would be at 0, 1. And there's your, this one is your secant graph. The secant comes off of the cosine. Now that's a secant graph. I've told you the amplitude is the absolute value of A, which is this length. The period is 2 pi over B. Excuse me. That's true for all of them except for tangent. Tangent does not have an amplitude, and tangent's period is not 2 pi over B. Tangent's period is pi over B. So if B is 1, what's the period? If it's pi over 1, the period would be pi. So that means on a tangent it goes from -1/2 pi to +1/2 pi. And there would be vertical asymptotes here. And the tangent curve should look like a lot like a cubic, but it's not. It's got asymptotes. So there's one cycle of a tangent curve. Yes, there are more. That's 0. If I moved over here, would be pi, and 5 pi over 3 pi over 2. 3 pi over 2 would make another one, 1.5 pi. And it does repeat, but again, I usually ask for one cycle or one period. So the tangent is a little different. It has no amplitude, and the period is different. It's pi over B as opposed to 2 pi over B. Now let's look at the last one of the 6, which is cotangent. I rarely ask you cotangent. It's very much like tangent. The period is still pi over B. Pi over 1 is pi, because the B is a 1 on this case. And what it does is it's a flip of the other one. It comes down like this. And this would be a cotangent. Anyway, I hope these help. We're going to start talking about changing periods, amplitudes, and then eventually phase shifts, which means left and right, and vertical shifts, which move it up and down.